Hi guys. Well, this video is a continuation of my previous video that is quite a while ago. A video I made about this DC converter, where I showed I explained how it works. I made a complete reverse engineering, and I mentioned that there are possibilities here for improvement. And interestingly, I got quite a lot of emails from viewers asking me if I can show what is possible to change here to make it work better and to improve it. So I thought, yeah, why not? And at the same time, a few days ago, I received my beautiful new tweezers, the SEQURE HT-140. I worked with them a lot before when I got them from a friend just to test them, and now I have my own. Thank you, SEGURE, for that. So I said, what's a better solution or a better opportunity to show you how to use these tweezers by changing or modding this DCDC converter. I will not use any other soldering station or soldering iron, just the tweezers. And I'll show you a little bit how I'm doing them with these modifications. The modification I mentioned are at least 3 modifications I can imagine. Let's go a little bit here. The first one is by changing these 2 sense resistors. These are these two. These are 10 milliohm resistors, and in parallel we have 5 milliohms. Probably not even 1% accuracy. That means with 5% accuracy we have over 5 milliohms, probably. And even if we have 5 milliohms here, we see at 25 amps, we have to dissipate more than 3 watts. That's too much. And this is why at a current of over 20 amps, these 2 resistors here get so hot to the point that they even desolder themselves. So this is very bad. This is the first solution, that is the first modification I would make, and probably the most important one, because not only they are getting that hot and you have problems with desoldering and all these other issues, very near to the capacitors, etc., but the problem is that it's very near to the voltage set trim pot that brings it, that with heating them up and down, this brings instabilities because the resistor changes here through the thermal differences. So this is a very, very bad design to put the trim pot or the setting pot for voltage or anything else near a very hot source. That this is these 2 resistors. Changing these 2 resistors is not just, yeah, okay, let's put two other ones there. You have to make a few changes here. First, I thought I will use a 1 milliohm, a single 1 milliohm resistor of 3 or 5 watt would be more than adequate, because at 25 amps we dissipate 625 milliwatts. That's perfect. But the negative part is that we are working in a quite low millivolt range, 20 to 25 millivolts. So I said, yeah, normally I would do that, and I would use a current sensing amplifier like an INA 180. That's a low side current sensing amplifier multiplied by, I don't know, 20 or something, and then feed it here to the TL494. But this is not possible, this design. I made this, of course, in my design. that will come somewhere in the future. But I said, okay, let's leave the 1 million and go to 2 millions at least. We're a little bit higher with 40 millivolts and 50, oops, this should be millivolt, not 50 volts. And not only one, but 4 milliohms, 1% in parallel. That gives us 2. So then again, we have at least a more even spreading of the dissipation that is necessary, that is 1.25 watts. And it sounds little, it sounds not much, but 1.25 watt just to the air, it's a lot, or in a closed environment. So the first thing that we have to do is if we use these 2 resistors, to desolder these 2 and change them to 4 milliohms each. I have them already here from a donor board. The second thing that we have to do is here, I don't know why, I said that in my previous video too, they use a resistor divider. It's already so low, they do it even lower. We don't need that. So this is, for this modification, we need to remove this resistor, the R19, completely. And here on the top, where you have the set point for the reference voltage, we have to change R2. And we change R2 to 300 ohms. It's not a complicated modification, but it needs a little bit of care. So here we have, where is it? Here we have the 2 current sense resistors, that's easy. Then here we have R19. Let's go a little bit closer. R19, I already put some flux so I can remove it easier. And back there, that's R2. So I hope you see it better. That's R2 and R19. We remove this one and change this one to 300 ohms. And for that, we use my new SEQURE tweezers. Blink, 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 blink. So, let's see how we will do it, because my space here is limited, and I hope I will give you some good footage to see I'm doing it, how I am doing it. So, I started already the tweezers. I'm going to 450 degrees, because there's quite a large ground plane here. And let's see if this is possible to use the tweezers to remove them. I already put some nice juicy shoulder, you see. Bye-bye. And the next one. Probably 400 would be enough, but just to be sure, let's remove a little bit the excessive solder. Okay, let's solder this one first. Just to hold it there. And then the second one. How does it look? Yeah, I've done it better, but under the camera, it is not that easy for me. The next one. Screw it a little bit down. So, I think we finished. Okay, let's put the away. Let's go to 350, or let's terminate it completely. And let's see what we did. Whoa, I have better solders. Okay, I don't like that at all. Let's start the soldering again. This is quite a lot of let's see how it looks now. Yeah, I will not win any award, but it looks okay. Next, the removal of R19. Okay, that was R19 removed, and the removal of R2 is a little bit more difficult here. Let's see if I can show it to you better. Like that. And it's gone too. Let's try to get tweezers directly soldered there. Did it work? Did it work? Okay. R19 removed here, and the other one, the R2, is changed to a 300 ohm. As I said, I will not get any award for my soldering under the camera, but let's clean it. Let's put a little bit isopropyl alcohol. And let's start to clean it. This is the way I'm learned cleaning these things using Kim whips. I use Kim whips since the 80s when I started development and prototyping development. So let's see how it looks. It's getting better and better. You repeat it as long as you get a discolored Kim whip. Let's put some more isopropyl. Here. And we do it here and here. So let it get a little bit wet to prepare it. And let's go here. It should be much easier. As you can see, there is a little discoloration. Then let's use an unused part of the Kim whip. I said an unused here to suck the ISO. Okay, continue here down. A little bit more. Starting to go there. And let's continue a little bit again here. That should be done. Dansky. So let's see what we did. Honestly, when it's clean, it doesn't look that bad at all. Get it a little bit dry. Okay. This is not very nice, but yeah, I'm not changing it anymore, just for you to show how it works. Anyway, this is the change that I wanted to show you today. We will try out how it works. Let me show you again. Yeah, these are the two old ones that have been removed. And the two new ones are 4 milliohms in parallel. Let's go back, and more back. Again, we change these two resistors from 10 milliohm each to 4 milliohm each, forming a 2 milliohm total that should produce at the resistor edges respectively 40 and 50 millivolts, as you can see here. 40 millivolts for the 20 amps and 50 millivolts for the 25 amps. That's of course with tolerances here. We removed this resistor here, the R19, the 10K, because we don't need a resistor divider, but we will still use the low pass filter formed from R18 and C20 to just clean a little bit the output going to the op amp, to the iSense here. And we changed this resistor, the R2, that's a 2K, and made it at 300 ohms. So the set point should be something around 50 millivolts here. We will see when we test it. And everything is done just with these tweezers. Nothing else used. Of course, it's not that easy, yeah? Because it's under the camera, and my setup here is not the best, not in any means, yeah? I'm using an iPhone, and yeah, I'm still struggling to find out the best setup for videos, or even more when I do things live under the camera. I'm avoiding that all the time because it doesn't look that good. But anyway, even with that, these beautiful tweezers worked very well. I had to go up to 450 degrees because of this big ground plane I had here, but after that there was no struggle at all. And please look at that, this tiny 0 point something tips. And why? Because I was lazy to change to the bigger ones. But I wanted to show you that even with that small tips, you can desolder quite large SMD stuff with a lot of ground plane. This was the first change I wanted to make, but this is the only one I will make for today. I will mention the other ones that I see that are possible. Perhaps in another video, or you can do it by yourself. I don't have to, because it's just changing capacitors and changing one resistor. Anyway, the next possible change and improvement is to raise the clock frequency of the TL494. This thing is working with 73 kilohertz at the moment by using 15K and 1 nanofarad as a timing resistor and capacitors. That's too low. We should go, let's say at least, because this will be divided here by 2 for up and low. I would suggest at least 100 kilohertz, or in my design, I'm going to 200 kilohertz. So at the end, you have 100 kilohertz. And you have to make 2 changes here. The first change is to change the timing the timing resistor from 15 kilo ohm to 5.1K. That's here. That's on pin 6 of the TL494, easy traceable and easy to find. And to change this capacitor here, the C2 capacitor, from 100 nanofarad, that is way too high, to a 6.8 nanofarad or something like that. Yeah, something a lot lower at least. That's for the feedback loop. They're easy accessible without any problem. As you can see here, cleaned, it looks much better. But even I had better solderings. Anyway, much better, but not under the camera. And the last change that I would suggest, if you really want to use this this DC-DC with less noise and less ripple, is to change the in and out capacitors. The bad thing is that for the sake of size, they are using very small capacitors, diameter capacitor with 10 millimeter. This is not that easy to find capacitors with very low ESR, with higher capacity and the higher voltage, because the left ones here, at least it says on the sleeve, should be 100 volts. But these are Chopax something. Okay, forget it. Yeah, I don't know if I can believe it or not. There are relatively low ESR. I measured it. It's not bad. Yeah, but there are way better ones. Yeah, and if you go to 25 amps, and stay with 73 kilohertz divided by 2, you should use larger ones. So when the load changes here, they can fill the gap, the current gap on both sides. And yeah, these are only here for ripple, not for the noise. For the high frequency noise, there are the small ones here, the ceramic ones. Yeah, anyway, this is not in any means a precision supply, nothing. It is just, yeah, just put a lamp behind that, or a fridge, a DC fridge or something, and use it. But you can improve it, first of all, with the changes I made here to make the resistors, to make the current, the whole current feedback and measurement way better in means of temperature and dissipation. You can go up to 200 kilohertz by changing only one resistor and one capacitor on the feedback loop, and you can change these capacitors. What do you use? Let me show you some stuff I bought from LCSC. LCSC is my main Asian supplier for quality parts, not AliExpress. Yeah, these are quality parts. For example, I have here 1000 microfarad, very low ESR, 63 volts, and they are diameter of 10 millimeters and 50 millimeters high. They are king size. They're not king size, they are high. But These are beautiful capacitors made for switch mode power supplies where space is a premium. These are 105, and these are genuine ones. Yeah, these are good ones. Huawei is using this, and Huawei is producing this too. Yeah, so these are very, very, very nice. You can change it, and looks like that. Looks a little funny, but anyway. These are the 63 volt ones, and then I bought some more ones with 50 volts, but a little bit lower on the height, just for fun, and they are cheaper. These are the more expensive ones, and we're not saying that we're not saying 50 of them for $1. Forget it. Yeah, what I paid here is at least I bought, what is it, six pieces. It cost me at least $15 or something. Yeah, and these are the other ones. I saw them many times on quality power supplies, on telecom equipment. You can choose what you want to use, and it's not necessary to go with 100 volt, except if you want to go, I don't know, up to 80 volts input or something. Who needs that? Anyway, I don't. So either you put the 63 at the input and the 50 at the output, so you can go up to 45 output and something 55 at the input, or you put the same in and out, then you can have at least 50 volts, 55 volts at the output too. These would be, I can show it to you again, these would be my go-to parts, just for you to see it. Normally I'm not doing that, but I will show you. These ones are the ones that I bought more. They are the cheaper ones. I bought, I think, 10 of them. Let's close it. How many did I bought? Do I see it? 15. Yeah, this is the number. The C number you can see here is the number from LCSC. And these are the more expensive ones. 1000 microfarad, very low ESR, 63 volts, and the diameter of 10 millimeters, and 5.08 spacing. As I said, for me, LCSC is my quality supplier from Asia. The primary one, and I have two others, but mostly I buy from them. Yeah, these are the changes I made. Let's continue. These are the changes possible, yeah? The changes I showed here today are only the shunts and the current loopback, the current feedback changes. Concerning the HT-140 SEQURE Tweezers, I'm extremely happy with them, honestly. I wanted to show you more in that video, but I made all the footage already, but this video is almost 2 hours with everything, everything here. So I'm dividing this video. I'm showing in this video only the changes on the current sense circuitry here, and a few thoughts what else can be changed by use of these very, very nice tweezers. Honestly, I cannot say it more times, because for that price, what they deliver is perfect. But there are some small quirks, but I will show you this in the next video. That means I made already the footage of a next video that shows much more of these tweezers, but not in the means of the, I don't know, hundreds of reviews on YouTube where they go through the menus, blah, blah, blah. No. What I'm going to use them for, how these tweezers help me in my daily work, why I like them, what are the things that can be better. This is the thing on the job again, yeah. I will show you some desoldering some quite large chunks, and you will see what they are possible, they are capable, even with this miniature C120 tips, yeah. Of course, there are bigger ones, but I'm making all the videos with that because if it works with that, with the bigger ones, it's a no-brainer. Okay, let's continue showing a little bit that the changes that I made here work, and yeah, we'll see what happens. Okay, I added my load. It's only a 400 watt load, unfortunately. The DCDC is set to 12 volts. I can still keep my finger on it without getting too warm. We are at 18 amps, and you will see when we start over 20 amps, it will start to regulate back. 19 amps, still okay, and at 20 amps we go back. 21 amps. This is the setting I made for 20 amps at the moment, and you see it's working good. Still 20 amps, and let's leave it a little bit longer. My thermal finger, my infrared finger, says it is acceptable. Of course, you can go even lower, 1 milliohm, and then you have to change accordingly. The R19 and the R19 is removed, but the R2, make it smaller. But this is at 20 amps on my older video. It was gone, yeah. It would start to desolder. And at 19 amps is the point where it starts to regulate. Yeah, this is what I wanted to show you. Oh, sorry. Of course, we have these cables, are getting warm already. These not, but these are getting warm. So I'm losing quite and I have problems probably here with the connectivity. Oh my God, the connectors are getting hot. So okay, this should be 12 volts, but I'm losing a lot of stuff. These are shitty banana plugs. I have to change them to something much better qualitative. Because look, if I move them, I'm getting all kinds of interruptions here. Yeah, look. This is not normal. Yeah, okay. So these things are getting warm, yeah. And this is why I'm losing. You see, now I've connected them a little bit better, and I'm losing less voltage, and that means that they are getting less warm, but they're getting significantly warm. And these are okay. You can still touch it without any problem. Anyway, this is what I wanted to show you. This is how it works. 20 amps, and it regulates back. So 20 amps is a lot. 19 and 20 amps is a lot. You can feel it and these are not Chinese cables. These are really cables, and I've connected them directly, as you can see here, to don't have any problems with these connectors, these cheap connectors. What's getting warm? Not really anything. The transistors are not getting warm. Here is nothing getting warm, but the capacitors, I feel the capacitors, and this is due to the ESR. These capacitors are not getting warm, but the input capacitors are getting warm. Cheapy, crappy capacitors. They should be changed. They are getting really warm at the point that I don't like it at all. These I have no problem. Okay, they are getting warm, but in no means like it was before. The coil is okay. So everything is okay, except of the capacitors. Yeah, that's it. Anyway, this is the major change I wanted to show you. A lot of noise from this one, this small fan, and of course this thing, yeah. Yeah, my cables are crap. Anyway, well, that's what I wanted to show you. Again, let's go to 20 amps and regulation back. Guys, if you like my videos, if you like what you see, subscribe my channel, give me a thumbs up, press the notification button, and as I said, there will be a dedicated video for these nice tweezers, because my primary thoughts to combine these two videos resulted to over 2 hours of video. It's impossible. Nobody will watch it. Anyway, thank you for watching. See you next time, and please stay safe, my friends. Cheers.